Good morning, Algebra 2 students. Welcome back to another virtual day. Today we are going to be focused on, I'm just going to enlarge my screen here just a little bit so it's easier to see everything. Oh, maybe not. So our schedule is currently on the right side of your screen right here. And so you can see the dates and things. So our test has been moved to Monday. We got a station rotation at the end of the week on Friday. You do have a quiz plus correction time in class on Thursday. And we have our last lesson moved till Wednesday. Now today, we're going to be looking at solving these problems, and you don't have to necessarily watch this. However, you can definitely use this as a guide to help you out. And so I'm just going to kind of talk through some of these problems. The steps are already set up there. And so I'll talk about one and then I'll go back to two, and I'm going to kind of cover things up as I go. So the first thing for number one is that I'm going to condense the left side of my problem. And so by doing that, this plus sign is telling me that I'm going to multiply the x minus 3 and the x minus 2 together. So I just show that step condensing right there, and then I drop down and I actually double distributed that out. Now I did not show the work, but remember you're just going x times x times -2, -3 times x, and -3 times -2. So we get that. And notice the right side hasn't changed. It's been a copy and paste all the way down. And I strongly encourage you to do that. Now, both of my arguments are stuck in an ln, and so I can get rid of my base and just set them equal to each other. And then when I do that, we get down here. Now, you want to be thinking, okay, so I moved everything from the right, from the right to the left side. So I did -2x minus 24, and I ended up with x squared minus 7x minus 18. Now you can think, can I factor that? Do I got to do quadratic formula? I always try to factor first. I'm thinking 9 and 2 is going to work here, and we show it right here. I get a -9 and a +2. So we solve, we use our zero product property, and that gives us a 9 and -2. Now you notice the -2 is crossed off, and that's because, remember, our argument needs to be greater than 0. So when I look at -2 and I plug it in into this very first one, into this very first log, I'll get -2 minus 3, which is -5. So since I get that, ln of -5 is not going to be a solution. It's not possible. So I'm crossing it off. So I'm crossing out the -2. Again, we want you to leave that solution, but cross it off just to show that you found it, but also show that you know it's not something that's going to work out. So number 9, or x equals 9, is our only solution. If I slide on over to number 2, I'm going to scroll back up here, and my goal here is a little different. My goal, instead of condensing this problem, is simply going to be to get the log by itself. So I'm going to subtract 15 from both sides. When we do that, we get the log 3, base 3 argument x equals -2. And so that can equal a -2. That's fine. That's actually truly my exponent. Some of you might be thinking, well, my answer is going to be 1/9, and if you don't get that, that's fine at the moment, because we're going to see how we get there. So to get rid of the log, I raise both sides to have a base of 3. And so this crosses my log and my 3 out. Remember, the base is that 3, so I use 3 for my base over here. And then it ends up giving me x, and then on the other side I get 3 to the -2, and that just leaves me with x equals 1/9. Now, remember, really what's going on here is you're just changing forms. This is just the step of showing how that change of base really works. So that's what we got for number 2. Sliding on down, we take a look at number 3, and this time it is similar to number 1. I do have to do a little bit of condensing for the problem, and this time I have to do two things. I'm going to take this 2, and in my classes I talked about going fishing. I'm going to cast that 2 back as an exponent on top of the 6. Now on the other side I got a minus sign, so that minus sign is screaming division at me. So I'm going to use that minus sign for a fraction bar and go x divided by 2. So we're sitting right here. We are looking at log 6 squared, 36, and then I got log x divided by 2. So sliding down just a little bit more, I end up with 36 equals x divided by 2. Now realize the logs got canceled because they're the same, so I can set my arguments equal to each other. We could also show that step of changing forms, but we don't need to. And so we get 36 equals x divided by 2, and we end up with x equals 72. Now if I take 72 and I plug it in for that x right there, obviously a positive number. I don't have to check anything else. It's good. Moving on to number 4, we got to get this e portion, that base, we need to get that base by itself. So I'm going to divide both sides by 3, which gives me e to the x plus 2 equals 3. Again, divided both sides by 3. Next, I am going to change forms. And so to get rid of base e, I need to use a log. And in this case, I'm going to use the log ln. So ln of both sides gives me ln e to the x plus 2. That cancels out. That's our inverse operation. On the other side, I just get ln of 3. Easy number to type in your calculator. And continuing on, I'm going to minus 2 from both sides, so I get ln 3 minus 2. And when you type that in, you get negative 0.901 ... something, something. But we get to round that, and so this is going to be our answer. Now, this is an exponent, so we don't have a domain restriction to worry about. Moving on, we have number 5, and it looks like number 5 is an exponent property problem again. So it's the same idea. I get my base by itself, that 2 by itself, and so I start by getting rid of this positive 6 by subtracting it. When we do that, we get x minus 5, and I am going to end up with 24, and I keep on going here. So now you notice that from this point, I introduce a log in the next step, and that's because I'm doing the inverse operation. So log 2 and 2 cancel out, leaving me with x minus 5. And over here, I get log 2, or base 2 argument 24. So I get x minus 5 equals log base 2 argument 24. And now I grab my calculator because I'm going to go plus. Remember, this right here is an exact answer. And right over there would be the decimal approximate. Looking at number 6, it looks like we have another solving problem. But this time, we are going to just cancel out the log. There's no condensing that needs to take place. So my base is 5, and so I go 5 to the power of log base 5, argument 3x minus 4. That cancels, that's the argument. And then on the right side, I get 5 to the power of 3. You can see now how once that log's canceled, we get to this point, and now it's a two-step equation, which I'm confident you can do. Moving on to 7 and 8. I'm not going to dive too far into these problems, but I will show the work and just make a few common things to look out for. When you look at number 7, you get plus or minus 10 because you're taking a square root all the way down here. Now, when you take that square root, that introduces the plus or minus sign, but then we have to check our log. So remember, if I go back to my argument here, I need that to be a positive argument. That doesn't mean x has to be positive. It just means the entire thing has to be. So if I look at negative 10, I'm going to draw this out on my Mac, which isn't ideal. But when I square that, it does give me 100. So that's a positive number divided by a positive number. So that's fine. That works out. And then 10 squared, positive 100 again. So it also works out. So in this case, both negative and positive 10 is going to be a solution, which is kind of unique. When I jump over to number 8, I'm doing some condensing again on the left-hand side. And it looks like by doing that, we end up with a quadratic inside the argument. And so I end up getting rid of that. And you notice I factor again here. Down here in the very bottom step, after I do my inverse operation and cancel my logs out, I am going to factor and then get a solution. Now remember, you have to check your solutions, and in this case 7 works out just fine. But -5, when I plug it in to that first log, it gives me -9, not an option, and so we cross off -5 for both of those problems. So just a few helpful hints to kind of solve these problems is, one, you always want to condense them if possible. Get to the most simplified form possible before moving on to anything else. You always then want to get your log or the base of the exponent by itself. So you're moving everything else away, any addition or subtraction. And then after that, you typically use the inverse operation of our log here or exponential function, which is the log. So they're just going back and forth, right? And then that simplifies the problem down to something you have done before. Hope you guys are staying warm and hope you can get this done. Please, please, please have this done so that you are ready to go for tomorrow. Have a great day, folks.